Hello everyone, my name is Jacob Tifo. I am founder and head engineer at Alpha Omega Rocketry. I wanted to first start off with an update on our XERXES flight. We are actually having to postpone our initial launch because the recovery equipment that we ordered got caught up in the holiday shipping chaos, and we'd like to ultimately recover our rocket. But in the meantime, I did want to show you some of the simulation that we've been working on. This right here is our Simulink simulation, and as you can see, it takes a thrust curve and TVC misalignment, runs it through vector analysis, inputs it into a 3 degrees of freedom equation block, and it outputs our angle of attack, our velocity acceleration, and a few other variables. And that allows us to run it through our PID block and have a complete system with feedback. This allows us to then, using the angle of attack and the velocity, we're able to calculate the drag forces and the drag moments. Also the lift moments, I should say. In order, though, to calculate the drag force and the lift forces, there is another variable that is necessary, though, and that is the coefficient of drag and the coefficient of lift. And we use this software in order to find those. This is Autodesk CFD, and as you can see, it's essentially a digital wind tunnel. These traces are simulating air flowing over the rocket at 20 meters per second. Also, these colors depict higher areas of higher pressure or lower pressure. Typically, the more towards the warmer the color, or more towards the red side of the spectrum, the higher the pressure, and more towards blue side or darker, it is a lower pressure. And as you can see in this flight, this is at 0 degrees angle of attack. The rocket is punching its way through the air, causing a area of low pressure where the air is then rushing back in to fill that void. We also have the simulation, which is at 5 degrees angle of attack, and as you can see, we have a little bit of higher pressure at the nose cone than we did in the other one, and we still have the area of low pressure in the back of the rocket, which we expect. But we also have this area of lower pressure along the side that is kind of like the interior angle, if you were to think about it in that way. And basically, by taking the wall calculations of the forces in the different axes in three-dimensional space, we can get our coefficients of drag, coefficients of lift, and also the coefficient of the side force. Coefficient of side force would come in handy if we were making a 6 degrees of freedom simulation, which is also underway. But that is just a little bit of the simulation that we've been working on. I did want to thank you all for tuning in. Hopefully we'll be bringing that launch to you very soon. We're very excited over here and are eager to get flying. And also wanted to say Merry Christmas, Happy New Year. Be responsible as if you're even if you're staying home or if you're going out and celebrating the holidays with family. I just hope and pray you all stay safe, be smart, and have a very Merry Christmas. Thank you.